Well, lucky you. I get to be in a warm state while you all freeze to death and have to listen to me anyway. To wrap up our chapter, we are going to be doing solving rational equations, and it flows naturally out of adding and subtracting because knowing the least common denominator is pretty much the essential skill right here. So whenever you have an equation and you're solving it, and we know we're solving it because we have an equal sign, what we want to do is clear the fractions. And in order to do that, we need to ask, well, if I were to add all these fractions, what would the common denominator be? And I see a 5, an x, and a 3, so I know that the common denominator would be 15x. And instead of getting that common denominator, I'm going to multiply both sides of my equation by that 15x. And then I'm going to distribute that 15x to all parts, all terms of my equation. The idea here is that the denominators will cancel. Now, it's important to note that this method of clearing is only valid if we have an equality. So if we had like a less than or a greater than, something like that, this method actually is not valid because we don't know whether x is positive or negative. So that would, the equality switches direction if we have a negative and we don't know what x is. So this wouldn't be valid if we had a less than or greater than, but it is valid for an equals. So I distribute this 15x, and you should see that 3 divided 15 is 5. And I have this 1 right here. So I have 1 times the 3 and 15 cancel. I get times 5x. And then I have this 3 right here. And notice on this one, the x's would cancel. So then I have 3 times 15. And then on the last one, 15 and 5 cancel. And I have this 2 right here. So the 15 and 5 cancel. That leaves 3x. And I have my plus. And at this step, I'm just going to simplify these. So I have 6x plus 45 equals 5x. And then from there, we really just solve it like any other equation. I'll subtract my 5x to get it over to the left, and I will subtract my 45 to get it over on to the right. And I have negative 45 on the right, and I have x on the left, and actually at that step, I'm done. Now, I do need to check my answers. There's no problem with this negative 45, but you could put it in here and just double check. You could graph it, see where it intersects. You could use your calculator solver to just verify that this answer is correct, but it worked out fine. So that is example 1. Example 2 we have over here on the right, and it's going to follow the same idea, except now I have a little bit more complicated of a denominator. So I want to treat these two denominators as each a group. And if I were adding these, hopefully you think, well, my common denominator would be x plus 3 and x minus 5. It would be both of those things. So I'm actually going to multiply both sides of my equation by those. So I'm going to multiply by x plus 3 and x minus 5, with the idea being that when I distribute this entire group to both these fractions, these denominators would cancel. Now, in the case of having one fraction on each side, you could cross multiply. So I could cross multiply this one and get 5x minus 25 and 2x plus 6. And that's something you should have done in like 9th grade, 8th grade maybe. But we're going to do it this way just because like that cross multiplying is the exception. Like over here on this example 1, we couldn't do that because I have two fractions on the left, so it's not valid. So we'll just practice this. All right, so we have 5, and then the x plus 3's you should see would cancel on that first fraction. I'd have x minus 5 left. And then on the right, the x minus 5's cancel, and I have x plus 3. I distribute the 5, and I get 5x minus 25. 2x plus 6. I'll subtract the 2. And then I'll add the 25. Don't really do that, equals. And since I made up most of these, who knows what will happen. So we get 31 over 3, And we are done. Now, since this is recording and you're probably watching this in class, you should, if I get ahead of you, just pause, but don't wait too long because there are a lot of examples and it is important to get to all of them. All right, so example 3 and 4. Now you should see we're really stepping up. I have a lot of fractions right here. And just like with the multiplying, dividing, adding, and subtracting, I really do need to factor. So in example 3, the first fraction is factored, the second fraction is factored, but this third fraction over here on the right is not. So the first step I'm going to do is go ahead and factor. All right, and you should think, all right, he's obviously going to multiply by, I'm sure someone yelled it out, either that or you're all asleep. I don't know which in this case, but we're going to multiply by x minus 5, x minus 3. And then we're going to distribute all of that to each of these. All right. So looking at that, I have an x minus 5 that's going to cancel with this x minus 5. So I have 1 times x minus 3. Oh, you know what? I forgot one of them, didn't I? An x plus 3. I need to multiply by that as well. Because this has an x plus 3, and this one didn't. Okay, anyway, so x minus 3, and then I'll have an x plus 3. Now this plus copies down, this x copies down, and then the x plus 3 should cancel with all the things that I multiplied by, thus leaving x minus 3 and x plus 5. Well, I'm going to get an x cubed right here. That's kind of scary. All right, and then we have 2. And then the x minus 5, x minus 3 is cancel, and I have an x plus 3. All right, I multiply all this out. I'm not going to go through an explanation of multiplying. You know how to do it. Right here, I will explain a little bit more. I would multiply these two things first. So this and this. So copy down the x. I get x squared plus 2x minus 15. And then equals, distribute this 2. And then distribute that x. And we keep going. All right, and we'll get everything to one side. This is a polynomial, isn't it? So we have x cubed plus 3x squared. Subtract this 2, and I get minus 2x. And then I have negative 24 right here, and if I subtract 6, I'll get negative 30, 0. And you see that we have a cubic right here. That would tie into the last chapter. So how do we go about solving this? Well, we would graph it and look where it crosses the x-axis. And then you use synthetic division. Now, I'm doing a recording right now and my calculator is not handy, so I'm not actually going to be able to show that. But your possible factors would be the factors of 30. So we're looking at 1, 2, 3, 10, 15, and 30. So, and 5 and 6, of course. So I expected that this would cross at one of those places and I could successfully synthetically divide. Maybe if there's time, I'll come back to this question at the end of the video and pull up the online calculator just to see what happens. But you would be expected, if you got a cubic, to go ahead and do what we did last chapter to solve it. So the new stuff is just clearing the fraction. So I'm going to focus on that. All right, example 4 doesn't look like that we'll have any cubics. So I go ahead and I factor. Be sure you're careful with your factoring, like make sure you're getting the right combination of pluses and minuses. And I should multiply both sides of this by x plus 2, x minus 1. Oh boy, maybe I do get a cubic. And x plus 1. That would be my common denominator. So I look at all of these and I'm multiplying so that when this distributes to all of these, that my denominator is clear. So I'll get 7 times, looks like I'll be okay, x plus 2, because the x minus 1 and x plus 1 cancel. Watch out for this minus, and then 2, and then I'll have x plus 2, x minus 1. And then on the right, I'll have 4 times x plus 1, because the x plus 2 and x minus 1 cancel. So that's what we're trying to have happen, is things cancel. I'll distribute the 7. I'll save this negative 2. Be careful. Multiply these first. Right here, multiply these two first. And distribute this 4. Distribute the negative 2. Take the negative with it. And then get everything to one side. So I'll have negative 2x squared. This will be 5x. Subtract the 4 minus 9x. I think yes. And then I have 18 with the 14 plus 4, so I'll subtract the 4 from the other side. And that gives me plus 10. Now I don't like negatives in front of my highest power, so I'll just multiply by negative 1 and thus switch all the signs. Alright, I don't know if this factors, but if it doesn't factor, I would be expected to use quadratic formula. Let's just try divide and slide. Don't know if it's going to work, but let's find out. So minus 20. So I multiplied this by 2. And then I'm thinking of factors of 20 that combine to 9. And I might think 5 and 4, but this is a negative. And I'm not going to get 9 and 4 to subtract to 9. So if this was a plus, that would work out, but it's not. So I don't think it is, therefore quadratic formula. So let's see what we get. Negative b is negative 9 plus or minus square root b squared, 81 minus 4ac, all over 2a, which is 4. And then I have negative 9 plus or minus square root. Let's see, this would be plus 80, so square root 161. Divide 4, there we go. So I think I should change this question so that this is actually a plus, and then it would work out beautifully. Maybe it was meant to be. Oh well. Anyways, going on. Let's see, this is example 5 and 6. And hopefully you see the tricks on both of these. Here we have a 2. Here we have a 1. Those are actually going to cause us trouble. And also we have that trick where these are almost the same. All right, if the denominator's not there, it's a 1. So it's 2 over 1. I'll factor this first one. I have x plus 1. I can factor out the common thing, which is an x. And so the common denominator in this one's pretty simple. X and x plus 1. I distribute that to all the terms. And the trick here is often that whole number piece will be forgotten. So I have 2. Nothing cancels on that first one. This 2. I have a minus. And on that, everything cancels. So just minus 1 equals 3. On this one, see this x plus 1 would cancel with that x plus 1. I get 3x. Now I'll distribute. I'll move the 3x over. And I don't know, does this factor? Let's try. So divide and slide. So I am going to double that, and remember to divide by 2 at the end. And luckily this does factor, unlike the other one. So I have 2 and 1 minus and plus. It's divide and slide, so I divided by 2 right here, multiply by 2, so I need to divide this by 2, divide this by 2, and slide it over. Well, actually this reduces to a 1 anyway. So I have x minus 1, and then this will be 2x plus 1. Alright, and that gives me 2x plus 1 equals 0. So x equal negative a half. And then x equal 1. So I got 2 answers out of that. Alright, example 6. Again, we have a denominator of 1 right here if it's not written. And then we have this minus right here. And it looks like this is very close to this one, right? So let's just reorder that to x plus 5. And then right here, like how could I get that to be close to this one? We'll factor out the negative. So make this 6 negative. And then switch these signs and I get x, well, not plus 5, minus 5. And then it's way easier. So now I'm going to multiply by x plus 5, x minus 5. So in general, you want your x to be positive if possible. So on the first fraction, we have the 16, and then the x plus 5's cancel, so I have x minus 5. Nothing cancels on that 1, so I have 1 times x plus 5, x minus 5. And then on the last fraction, we have negative 6, the x minus 5's cancel, and that leaves me with x plus 5. So I distribute that negative 6. I'll multiply this out. That's x squared minus 25. And then I have 16x minus, let's see, 80? Hopefully. And then a plus. Don't drop that plus. All right, give everything to one side and in order. So I have an x squared. And then I'll add this 6x, so that gives me plus 22x. I have negative 80 and negative 25. That's negative 105. And then I'm going to add this 30 to it, but it's actually subtract, right? So that's what, negative 75 equals 0. And I'll attempt to factor that. I hope it factors. So factors of 75, negative 75, that will give me 22. I'm thinking minus 25 and plus 3. Or actually, I'm thinking plus 25, there we go, and minus 3. All right, that gives me x equals negative 25 and x equals 3. And those are my answers. Now, I've actually, in all of these, been skipping a step, and that's to consider that there are sometimes cases like if I had done all of this, and I say I'd gotten x equals negative 5, well then obviously up here at the top, that would be a problem, right? I can't have a negative, so we're going to want to definitely consider that. And so that gives us our next key idea, which is that we should state restrictions. And we should actually kind of do that first so that if we run into either of those answers, we know that that answer isn't going to work. And we have a term for that. It's called extraneous. And extraneous means that we do all the mathematics correctly, yet still that answer does not work because when we check it, it fails. So in this case, and we are on example number 7. I assume since it's under this that does happen. We're going to do all the math, but I'm going to do that first step this time. So we're going to state our restrictions. So I see right here that we're going to say note on this example. x cannot be negative 2 because that'd make this first fraction the denominator 0. You cannot have a denominator of 0. Numerator 0 is fine, but denominator 0, that's no good. And we also note that x cannot be negative 3 because of this last fraction. And the middle fraction, well, when I factor it, I get x plus 3 and x plus 2 anyway. Now I'm going to start to do all the work. So I'm going to multiply by x plus 2, x plus 3, and I'm hoping that that cancels some things. So I get x, the x plus 2's cancel. Then I have 2, everything cancels, and then 5 times x plus 2. That gives me x squared plus 3x plus 2 equal 5x plus 10. And get everything to one side, I have x squared minus 2x minus 8. That factors to x minus 4, x plus 2. Remember, when we have a quadratic or a polynomial, we get everything to one side. And then just continuing that, that means x is 4 and x is negative 2. Now, if we hadn't have stated these restrictions, we might be tempted to box both of these answers, but actually this x negative 2 does not work, and we label it as extraneous. And why is it extraneous? Well, if I put negative 2 into here, this denominator is 0, and actually if I put it in here, this denominator is also 0, and we can't divide by 0. So we have to reject that answer. So we should always state our restrictions and check our answers. Also note, we are looking for this chapter only for real solutions. So if we were to get i's complex numbers, we can go ahead and ignore those for this chapter. All right, so this is example number 8. And I'm going to start by factoring. And I note x cannot be 5. X cannot be negative 2. Otherwise, I continue like usual. I'm going to clear by multiplying by the common denominator of x minus 5, x plus 2. And I distribute that to all these terms. So on the first fraction, the x minus 5's cancel. So I have x times x plus 2. Then plus 3. The x plus 2's will cancel, so that leaves x minus 5. Then on the last fraction, everything cancels, and I just have that 7x. I distribute the x. I distribute the 3. Combine like terms. Get everything to one side, so subtract that 7x. Watch your signs. Factor. And then x is 5, or x is negative 3, and this 5 is extraneous, so we just get negative 3. And that's why we always state our restrictions at the beginning, because it's very easy to get in the flow and then ignore that. All right, let's see how many we have left. Just a few. All right, 3 more, so we're on example 9. So first thing we should do, factor. Next thing we should do, state our restrictions. X cannot be negative 2. X cannot be 2. Because that would make these denominators negative. Or not negative, 0. Multiply by the common denominator, whatever that happens to be. Distribute. Then I get 3x times x minus 2 minus x times x plus 2. What am I doing? The x plus 2's cancel, so this should be minus. This one, everything cancels, so that should be gone. And then over here on the right, x minus 2. So, don't know. My brain discontinued. Alright, so we have 3x. Distribute the negative, so negative x squared plus 2x. And distributing 1 just gives this back. Alright, get everything to one side. I'm actually going to choose the right just to save steps. Add the x squared over. This is 5x, so subtract that over, get negative 4x. And then minus 2. Why do I feel like this is wrong? Alright, so let me double check everything. We have 3x. We're clearing by x minus 2, x plus 2. So these cancel. So there's 3x. I have minus x. That's good. X plus 2's cancel. So I have x minus 2. Now, no, I don't need to do the x plus 2 twice. Like, just by having it once is good enough. So we have the x minus 2 equals, and then an x minus 2. Distribute a negative. That's good. And then this would be negative x squared plus 5x. Subtract that. That's good. And then, I guess that's good. All right, well, I'm sure someone will tell me sometime. All right, so this doesn't look factorable, so I'm just going to go ahead and do quadratic. So 4 plus or minus square root. B squared, nope, B squared should, this number right here, always positive, always positive. If you're typing in, if you type in negative 4 squared in your calculator, you're going to get negative 16 right there, and that is wrong. It should be plus, so just do that, make sure it's a plus. Minus 4ac all over 2a, so 2 times 1. So x equals, we have 4 plus or minus, and then this is plus 8, so this would be root 24. Now remember to simplify root 24. We will eventually be doing a chapter on this, but the biggest perfect square that divides 24 is 4. The square root of 4 is 2. So we get 2 root 6. Now some of you all, this is just like a side step thing. Like some of you, I don't know why you're doing this. Like you're writing down in homework, like you write square root 100 and then you write equals root 10. No, just 10. Like you did the root. It goes away now. Now, so when I do this root 4, I don't do root 2 times root 6. That would be wrong. I did the root of the 4, so it's 2. Just the 2. So I have 4 plus or minus 2 root 6. And then this 2 divides both these things. All right, so up here, 4 divide 2 is 2, plus or minus, and then 2 divide 2 is 1, root 6. All right, so I didn't need any extraneous. This says contradictions mean no solutions. So, I wonder if I was supposed to not get this. So, we'll just put vote of no confidence on this question. All right, 10 and 11. All right, I'm going to just pause for a second. I want you to try both of these on your own. State your restrictions. And then attempt to solve them. Then unpause the video, check to see if you did it right. So go ahead, do that now. And hopefully you have unpaused and have attempted these. We have x plus 5, x minus 4 right here. And I'm going to note x is not negative 5, x is not 4. I'm going to multiply both sides of this equation by x minus 4, x plus 5. So I get x times x plus 5 minus, I'm going to have to be very careful of that minus, x minus 4 equal 36. So I have x squared plus 5x minus 4x plus 16 equal 36. That gives me x squared plus x minus 20 equals 0. I factor. And then x is not negative 5 and x is not 4. What do I mean not? X is negative 5. X is 4. Of course. Wait a minute. That wasn't actually. Didn't we state up here? We can't be those things. So we reject actually both of these answers. So what does that mean? No solution. And this one, factor, multiply by the least common denominator. So I'll get x minus 3 plus x times x plus 1 equal 4x. We get x squared plus x. We combine like terms. Don't forget the plus. Subtract the 4x. Factor. I get x equals 3. X equals negative 1. Of course, at the beginning, I should have noted, we can't actually have either of those. So again, no solutions right there. All right, that wraps up the chapter. Good luck on your homework.